Alright, our goals for this lesson are going to focus on histograms, being able to create and interpret, and then continuing with our ability to describe the overall pattern, and then the strengths and weaknesses of a histogram, and then be able to compare distributions using a histogram. So by the end of the lesson, you should be able to answer these 3 questions about histograms. Alright, so I want you to look at this histogram and just what do you see? I have a series of questions. How many students had a grade between 80 to 85? How many students had a grade of an 80%? For the one student that was in the 100 to 105 range, what was his or her Algebra 2 grade? How many students do we have grades for? About what was the average Algebra 2 grade? Which interval is an 85% in? And what is the average grade? So I just want you to think through those questions, look over this histogram, and see how many of those, if any, you can answer. Alright, these are our vocabulary words for this lesson. We're going to be talking about these 7 terms as we work through this lesson. Alright, so first we're going to start with, this is our actual data from our class, our weighted GPAs. And we're going to be talking about different types of frequency. So we have a frequency distribution, which just shows the number of instances a variable takes a specific value. Relative frequency, which tells the frequency of a value in comparison to the whole. So relative frequency is always a percentage. And then this idea of cumulative frequency. So cumulative means over time. I'm continuing to add to it. So it's the sum of a class and then all the classes behind it. So we will make sense of those terms as we move through this lesson. But when we're given large amount of data or data that takes on many values, it is helpful to group the data to effectively display it, and we use that idea of frequency. So how often does something take on a similar value? So you'll probably want to pause the video now and write down this data, weighted GPA. We're going to be working through and analyzing that as we learn about histograms. Alright, so a histogram talks about frequencies or relative frequencies, which is percents of values in equal width classes. So essentially we're grouping them into what you may have heard me refer to as bins or classes. So that's what a histogram does, is we group data and then see how often things fall into that. The other term that you need to know is class width. So this is the difference between the upper or lower class limits of 2 consecutive classes. So I will explain what that means in just a minute, but let's go ahead and make a histogram. So I went ahead and took our weighted GPAs and I grouped them, and they have to be evenly equal width classes. So for this frequency table, I went ahead and said a 1 to a 1.4, a 1.5 to a 1.9, a 2.0 to a 2.4, and so these GPAs. And if you notice, from 1 to 1.4, I have 1.0, 1.1, 1.2, 1.3, 1.4. So that's 5 GPA values. And then a 1.5, 1.6, 1.7, 1.8, 1.9, that's also 5. So if you notice, I don't want to go 1 to 1.5 because that's actually 6 values, and that would leave a 1.6 to 1.9, which is 4 values. I need them to be equal width. So I can tell because 1, 1.5, 2, 2.5, 3, 3.5, 4. So I can see that. So when I look at the count, I tallied up where most of our GPAs fell. And so we're going to put it on the histogram. So the GPA is going to go on the x-axis. And I set up my intervals. So this would represent 0 to 0.5, 0.5 to 0.9, 1 to 1.4, 1.5 to 1.9. And so we're working through that way. So now I just need to create my frequency. So when I look at this, 10 is the highest. So my y-axis has to go up to 10, but no higher than that. And now I just need to draw in my bars. Now, what to keep in mind is that the left-hand limit is going to be going from that 0.5 over, from the 1 over. The histogram, that's where when people are creating histograms, it gets a little bit tricky. So from 1.5 to 1.9, I had 1, so I went up 1. From 2.0 to 2.4, I had 0, and then 2.5 to 2.9, I had those 4. And then my highest was 3.0 to 3.4, which was 10, and then 3.5 to 3.9, I had 4 again. And lastly, there are 3 people in our class that have a GPA higher than a 4.0 for their weighted GPA. So I can see the distribution a little bit better of all those numbers when I group them together. So my class width is the difference between the upper or lower class limits of 2 consecutive classes. So that's kind of a confusing definition. Essentially, it's what's the difference between this lower limit and this lower limit, or this upper limit and this upper limit. When I look at those numbers, these are easier. So what's the difference between a 2.0 and a 2.5? Well, 0.5. So my class width for this histogram, I went by halves, half of a GPA point. So that's what that's talking about. I could also do 2.9 minus 2.4, and that would also give me 0.5. But these are just easier to see. All right, so I want you to look at these 2 histograms, and I want you to just look at and think about, what do you notice about the 2? So just kind of make a list of things that you notice about these 2 histograms. Hopefully you're able to see that this is the histogram we just created. So my GPA with my class width of 0.5 and my frequency, and it had that normal, roughly symmetric shape. And then over here I noticed it's the exact same layout, except for now we still have that same class width, but now we're talking about percentage. So we knew that there was one person who was in a 1.5 to a 1.9. Well, now it's 1 out of the 22 that were in here. Now it is, this was 4, so 4 out of 22 is roughly 20%. 10 out of 22 is almost half, so it's up there. And so if you notice, when I make a percentage, or I do that relative frequency, relative meaning in comparison to the whole, I still have the exact same distribution. All right, here's some just basic information about histograms. There's really no right choice of the number of classes. The general rule is to keep your classes between 5 and 20. So if we think about the histogram that we just made, my classes were 0 to 0.5, that's 1, 0.5, 0 to 0.4, that's 1, 0.5 to 1, that was 2 classes. And so when you look at the x-axis of that histogram, or if you look at the frequency table, you can see that I have 8 classes. It was just easiest to make them in 0.5 class width. Just some words of advice: if I have too few classes, then more data is going to be lumped together. I'll have a skyscraper graph, and if I have too many classes, it's going to give a pancake graph, so I'm not going to be able to see the true distribution. Classes must be equal width, so don't play tricks with the eyes. Use relative frequency when you're using histograms to compare data with different number of observations. So relative frequency is that percentage. So when you're comparing maybe a class of 22's GPA to a class of 50, I'm going to see with the class of 50, it's going to look like there's a lot more A's and B's and C's, when in actuality, when I compare using percentages, I'm going to be able to see compared to the whole of each individual one, and that's going to help me compare them better. And then condense the data, but don't miss important gaps. So try to put as much as you can together, but if you put too much together, if your class width is too wide, you might miss gaps. And I have that kind of illustrated here. So this is the same information as this, but by putting my class width too wide, I miss that there's none here and here, whereas in this graph, you can see that it's filled in. But it's because I had grouped them using a wider class width, so maybe these ended up being together. And same thing over here. This is just this graph with smaller class width, so I can see the breakdown a little easier. All right, so we have created histograms, so go ahead and pause the video and make some sort of interaction that will help you remember what you've just learned, important information, questions that you have, or things that you want to make sure you remember when you go to study. All right, so this is our same histogram that we've been using. I would like you to take a minute and pause the video and describe the overall pattern. So talking about shape, center, spread, and outliers. All right, so hopefully you were able to identify that it's roughly symmetric, that the center is about a 3.0. Now, we can't say exactly what it is because all we know is that there were 10, if we hadn't looked at the table, we know that there are 10 students who were between a 3 and a 3.4. So it's going to be somewhere in that range. So I'm just going to say it's about a 3.0. If you said somewhere 3.0 to 3.4, that's going to be about the middle of that data. The spread, I'm going to say the data vary from about 1.5 to 4.4 because I don't know exactly where this one person is. They could be a 1.5 or they could be a 1.9. I don't know. And the same with over here from 4 to 4.5. All three of those people might be 4.0s. But with a histogram, I see a class width, and so I have just an interval that I can talk about. And there do not appear to be any outliers. And the last thing I want to talk about is sample size and class midpoint. So sample size is just the number of observations. You're going to hear sample size a lot in statistics. And if I didn't know there were 22 students, I could look at this histogram and say, okay, I can tell that there's 1 here. I can tell that there are 4 here. I can tell that there are 10 here, there are 4 here, and there are 3 here. And when I add up 10 plus 4 plus 4 plus 3 plus 1, I should get 22. And so I can, if it's not a relative frequency, so if it's not percentages over here, I can tell the sample size by just looking at the bars and where they land. Okay, the class midpoint. This is a definition that you do need to know for the dual credit statistics. You're not going to see this a whole lot, but I do want you to have exposure to it. So the class midpoint is the average class value. So when we're talking about class, we're talking about the distance of one interval, basically. So we're talking about a 2.5 to that next class that starts at 3. So this one is the upper limit minus the lower limit divided by 2. So essentially, if I were looking for the class midpoint of this right here, I would take the upper limit, which is 3, minus the lower limit, which is 2.5, and then I would divide that answer by 2, and I would get a 2.75. And you're going to need that for later when you talk about finding an average. That's one of our standards as well, is when we take a histogram and we analyze it to find an average. But that's that process of finding the class midpoint. I'm just basically looking for the middle point of each of these classes. All right, you can now describe the overall pattern of the data. So if there's anything that you need to remember or remind yourself of, then pause the video and have an interaction. All right, so interpreting a histogram. So at the beginning of this lesson, I asked you a bunch of questions, and I want to talk through those questions now and see if we can answer them. All right, so the first question, how many students had a grade between an 80 and an 85? So when I look at this histogram, an 80 to an 85 is right here, and so right there when I look at it, I see that there are 4. The next question, how many students had a grade of 80? So the drawback of a histogram is that I can't tell precise values and how many fell in that exact spot. So I do know that the 80 is right here. There is a possibility that there are 4, that all 4 of those in this category are 80s. But there's also a possibility that none of them are 80s and the rest of them are 82s and 83s and 81s and 84s. So I actually can't answer this question of how many students had a grade of an 80 based off of a histogram because I only know an interval that's occurring, that class from 80 to 85. I know how many fell in that interval, but not specifically within the 80. All right, so the next question, for the one student in the 100 to 105 range, what was his or her Algebra 2 grade? So again, when I look at this, I see that there's one student. I do not know what the specific grade is because it's in that range of data. So I can't answer that question either. right? How many students do we have data for? Well, since this is frequency and not relative frequency, a percentage, I can actually count up. So I see that there are 3 here, 3, 4, 3, 7, 1, and 1. And when I add those all up, I get 22. All right, so for this next question, about what was the average Algebra 2 grade? So this is where we're going to use that class midpoint to determine the average. All right, so I know that 3 people had a grade between a 70 and a 75. So what would be the midpoint between that 70 and 75? 5. Well, they're 5 apart, so halfway would be a 72.5. So we're going to go through and we're going to calculate what the midpoint of each of these would be, because we're saying, okay, I know that there are 3 people who fell in there, so let's just take the middle and give that value to those 3 people, because hopefully that would average out at some point. So this is going to be a 72.5. This will be a 77.5. This is an 82.5. This would be an 87.5. This is a 92.5. This is going to be a 97.5. And this will be a 102.5. So essentially, I'm just finding the middle of that class width. Well, if 3 people, let's say, averaged a 72.5, and 3 people averaged a 77.5, and 4 people an 82.5, and 3 people an 87.5, and so on and so forth, I can find the average the same way. I add them all up and divide by how many there are. But instead of knowing the exact value, we just gave these 3 people an average of a 72.5. So I'm going to have 72.5 plus 72.5 plus 72.5 plus 3 77.5s plus 4 82.5s plus 3 87.5s plus 7 92.5s and one 97.5 and one 102.5. And when I take all of those and divide by how many there are, which is 22, I end up with an 85.95. So we're going to say, based off of this histogram, we're giving about an average grade of an 85.95%. If that does not make sense to you, please make sure that you mark that so that we can talk about it tomorrow. All right, our next question, which interval or bin is an 85 in? All right, so a histogram can sometimes be a little deceiving because these markers right here, I don't actually know which bin this 70 goes with. Is 70 part of the previous one, or is it part of this one? Does this bin start at a 71 to a 75? And then a 76 to an 80, or does it go a 70 to 74? So that's one thing about histograms that can be a little bit confusing, is knowing those breaks, which bin are they part of? So we actually can't answer that because we're not sure based off of the data that we're given. Now, when I look at this, I tend to think that 70 to 74, because it starts at 70. So then 75 to 79. So that would put an 85 in the bin from 85 to 89, but it could be part of the 81 to 85 bin. We aren't really sure. And we've already answered that question. So that is interpreting a histogram. Go ahead and pause the video and have an interaction. Write down any questions that you might have, or steps, or things that you're going to need to remember that are new learning for you. So when I'm comparing the distribution of 2 histograms, the things that I should be comparing have to do with the things that we analyze when we look at that overall pattern. So I'm looking for shape. So if both are skewed, which one has a longer tail? I'm looking at the center, which has a higher center, so more frequency in that spot. Spread, which one has more variability? So variability is the distance from the smallest number to the largest number. So I'm looking for which one is more spread out. And outliers, which has outliers that are more extreme. All right, so I have 2 histograms The first one is our test scores in Mrs. Smith's first block class. And then the second one are test scores in her second block class. And I want you to use this information. A 69 and above is passing, and a 68 or below is failing. So when you look at first block and second block, I want you to go through and answer these questions as true or false. All right, so the first one, the same number of students passed the test in both classes. So if passing is a 69 or above, when I did this cutoff, I saw that 5 plus 7 plus 6 plus 4 is 22, so 22 passed. And over here, 3 plus 6 plus 7 plus 6 is also 22, so that is a true statement. So when I first looked at this one, the first block did better than second block. I looked at this and it looks more compact. This one is skewed left and this is roughly symmetric. So my inclination was to say yes, but when I started looking at it a little bit more than just the spread and more than just the shape, I looked at it and I noticed that if an 85, let's say, is a B and a 93 is an A, first block only had 10 people get A's or B's, whereas second block had 13 people. And so they had more students do better, whereas first block was closer together, but there were 7 C's and here only 6 C's, 5 D's, and only 3 D's. And then they both had 3 that failed. So I actually would say that this is false. I would say that second block overall did better just because they had more A's and B's. All right, more students took the test in second block than in first block. That is false because they both had 22 pass and 3 not pass, so 25 students took the test. There are outliers in both blocks. I would also say that is false. The only one that had an outlier was probably this second block class because these over here are pretty close together. Both distributions were roughly symmetric. I would also say false. First block is roughly symmetric. However, we said second block is actually skewed left because it has an outlier pulling that tail out. The average score in first block is higher than the average score in second block. All right, so this is a great chance to practice finding the average. So remember, you're going to look at the bin width. You're going to find the average of that class average. So when I think about a 61 to a 68, how far apart is that? Divide it by 2. Find what's about in the middle, and then you'll find the average by adding them all up and then dividing by how many there are. So when I did that, I knew that the class midpoint for this bin was going to be halfway, which was going to be a 64.5. And so 3 people had a 64.5. So I could have written 64.5 plus 64.5 plus 64.5, but it condensed it a little to say 3 64.5s. Then I found the class midpoint of 69 to 76, which is a 72.5, and 5 people had that. 7 people would average an 80.5. 6 people averaged an 88.5 and 4 people a 96.5. And so when I added all that up and divided by the 25 students it represented, I got an average of an 81.46 for first block. And when I do the same thing for second block, I get an average of an 82.1%. So their actual average score or their estimated average score is higher in second block. So that kind of reinforces my prediction about the students doing better in second block than in first block. So the average score in first block is higher. That is false. All right, so you have now compared distributions of quantitative data. So go ahead and pause. Think about the things that I did. Do you have any questions? Do you have any things? What are you going to need to remember? What makes sense to you? Have some sort of interaction in your notes. And finally, a histogram. The advantages of a histogram is if I'm using really large sets of data, I group them together. It's a lot easier and faster to graph than doing individual dots, like a dot plot. If I'm also working with really large spans of data, so if my data goes from 0 to 600, a histogram is going to be a lot easier. It's easy to observe an overall pattern. It's right there in front of you. You'll notice that statisticians use histograms a lot. And it's easy to make generalized comparisons of data. So when I look at 2 histograms, it's relatively easy to be able to compare those. The disadvantages of a histogram is that it's only for quantitative data. So remember, we use a bar graph for categorical data and a histogram for quantitative data. And just a reminder, when I'm using that bar graph, there's spaces between the bars, and for the histogram with that quantitative data, the bars touch. I can't see actual values, just intervals. I can make some estimations, like when we found the class midpoints and averaged out that way, but I can't see the actual values. And it's really easy to manipulate for misleading data. So when we looked at those two graphs, if I group things larger, I'll miss those gaps, but if I group them too small, then I'm going to see a lot of data that isn't necessarily what I need to look at. So those are the disadvantages and advantages of a histogram. So your last thing is to pause the video and have an interaction about the advantages and disadvantages, or being able to talk about the strengths and weaknesses of a histogram. And as always, here are just your definitions in one place. Have a great night.